Okay, guys, we're back here for 12.2. In lesson 12.1, we learned how to find different terms of a sequence, and that's just a list of numbers. Now, when we get into series, it's the sum of those put together. So we're going to be looking at the sum of the numbers that we have, and again, we'll indicate that sum with the subscript. So again, the subscript will tell you how many terms that we want to take. So like if we want the first term, if we want the sum of the first two, sum of the first three, that's kind of how we indicate that with an S, meaning that we want the sum. Now another interesting way of writing this is using what's called summation notation. We use the capital letter, Greek letter sigma. You see that before, kind of a fancy E it looks like. This tells us the term that we're starting with. Most often we start with 1, not always, but most often we do. 5 is where we're going to end. We can end anywhere we want to. That'll tell us how many terms we have. So basically what you do is you put these numbers in for the explicit formula that we talked about last time, and write out all the numbers. And then what we're going to do is we're going to add those up. And the table mode of your calculator can be very handy, and we'll get to that here in just a minute when we start expanding these. Now, writing these can be kind of difficult because if we want to write the explicit formula, all right, so we got to count the terms 1, 2, 3, 4, 5. So what I would do is first of all figure out how many terms, and I'd usually start at 1. Normally that's a good idea. Start at 1, go to 5. So there's 5 terms. Now, coming up with a rule, now remember we did that in 12.1. Well, we can know that we're adding 4 every time, so we know it's linear. So 4 is your slope, 4k. We use k for summation notation. And then, of course, the 0 term would be the one before this, which would be 0. We don't put plus 0, but it's there. So that's how we can get that regular form. So we want to be able to write it in summation notation. All right, let's try another one of those. All right, so here we see that we're going negative, positive, negative, positive. And what happens there's kind of a rule here. If they alternate positive to negative and you start with a positive, this is what you want to put. That'll take care of the alternating. If it starts with a negative number, though, we want to put negative 1 to the k. So that'll take care of the alternating plus minus that we have. All right, so now we go back. We got to come up with the rule. Well, we can see here that this is 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 4 squared, 5 squared, 6 squared. So our formula is going to be 1 over k squared. Kind of kooky. Sometimes it takes a while to kind of get used to these, but yeah, writing those explicit rules can be tricky. That is for sure. But remember those how to alternate. Okay, how to alternate plus to minus, whether you start positive or negative. This is kind of a good screen to go refer back to, and I'll have those PowerPoints up for you to look at when you're working on stuff. All right, how about this one? Let's kind of write this one again. We're starting negative, positive, negative, positive. So again, if we start negative, we want to have that negative 1 to the k. That's what we're going to have first to take care of that negative. And then what's happening is we're going 2, 4, 6, 8, going up by 2's. Once again, we have a linear equation. So 2k, and obviously we would go back here to would be at a 0, so there's nothing to do there. So just 2 times k is what we would have there. All right, so that's writing summation. Now once again, 1, 2, 3, 4, 5. I think I'd have this. I went. Well, if it says write for the first 6 terms, I guess you'd go 1 to 6. But in this case, 1, 2, 3, 4, 5. I would have just done 1 through 5. But since they said 6, I'd go 6 here. All right, here's another one. Now, this time we're going to expand the series. So they're going to give it to us. This time, look at this. We're going to start at the second term, and we're going to go to the 5th term, and we're going to use the rule 1 over 3 to the k. Here's a great way to do this. What you can do is go to your calculator, hit the y equals, and type in the explicit rule, 1 over 3 to the x power. All right, then you can go ahead and make a table. And look at that. Now, we're only looking at terms 2 through 5. So what you would do is you'd write 0.11 plus 0.83 plus 0.81 plus 0.88. We'd get those numbers down, and then we would add them up. So when it says expand the series and evaluate, we want to add those. Now, again, on the slide that you see here, they did the fractions and then added those up. I'd just go ahead and use the calculator. Decimals are perfectly fine to use in that case. Okay, all right, let's see about another one of those. If we expand, all right, this time we're going from term 1 to 6. So we'd put a 1 in for k, a 2 in for k. We could all do this very easily by putting in k squared minus 10 in the y equals. And then what we would do is then, certainly we could just kind of use the table mode there, and we'd get these numbers. And then, of course, the evaluate part is just to add those up and get 31. So easy enough. Again, table mode is a great way to do that. You can use this, however many of these that you want to. Like I said, using the table mode is the absolute best way to do those, especially if they're kind of difficult. Now here's some interesting concepts here, is that what if we have what's called a constant series? There's just a number here. If I do terms 1 through 5, and my rule is 3, well, that just means every time I get a 3. 3, 3, 3, 3, 3. So a simple way to calculate that is 5 times 3, which is 15. So again, this is kind of a general way of showing if you have a constant series. All right, now what if you have a linear series where you just have a k out in front? Well, the numbers 1 through 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can list them out. Well, look what happens here. When you take the first and the last, the second and the second to last, they add up to the same thing. So a simple way of doing this is just to add the first and last numbers, which is 11, and then multiply that by half the number of terms that you have. And a ruler that you have. And again, nothing wrong with putting it in the table mode and brute forcing it. That's certainly fine as well. But again, you can kind of come up with a linear equation here. We're coming up with this is you can take n times n plus 1, and what you can then do is divide it by 2. It's kind of a simple way of doing that. Here's some just kind of general rules. Again, nice to have those PowerPoints. If you have a constant series, just take the number of terms times whatever that c is. If this is a linear term where it's just a k, yeah, just take n, take one more than n, divide it by 2. That'll come up with this. And then this one's an interesting one. If it's quadratic, you're going to take n times n plus 1 times 2n plus 1 divided by 6. Kind of interesting formula there that we can use there. Now, one thing to keep in mind is that careful. Now, if you start at 1 and go to 10, yeah, there's 10 terms. But be careful. If you start at 5 and go to 10, some people might think it has 5 terms. But if you list them out, 5, 6, 7, 8, 9, 10, there's actually 6. So be careful. If you don't start with 1, yeah, be careful counting how many terms there actually are. If it is 1 to 10, you know it'll be 10 terms, but in the other case, that's what you'll have. Okay? All right. Well, good luck. Try the worksheet on 12-2. Again, contact me via email if you have any questions. Best of luck to you. And until next time, I'm Mr. Boone.